Okay, so I'm going to go ahead and mute everybody, and we're going to get started. Um, I do want to go ahead and tell you right now, at some point, you are going to get confused, but hold on. Let me get through my spiel, and then we will do questions, okay? I practiced this, going through it step by step by step to make sure that I would clear up any confusion that people would have, okay? So I would just want to, y'all just hold on. I promise you, you're probably going to have moments where you're like, "What is she talking about?" But my plan is that I'll review all of that and answer your questions. Okay. So we're going to talk real quickly about what this concept is using these notes, and then we're just going to launch into working problems. My goal is to work 2 empirical formula problems and 2 molecular formula problems. Then if we have time, we will work one that goes together, empirical and molecular, in one. If you get confused, this video will be on YouTube. It may not be until later on this afternoon because I've got to get home where I have better internet, but I'll put the video on YouTube. And the beauty of that is you can watch me work a problem and pause it, work some of the problem and pause it, and then you can go and refer to your problems that are in your packet. So a lot of you have started working on some of the stuff that needs to be turned in, and I do want to point out that this graded assignment, pages 10 and 11, as well as this complete worksheet number 3, these two are going to require you to know how to do this, okay? So keep that in mind. All right, so let's go ahead and talk a little bit about what molecular formulas are, what empirical formulas are, and how we can determine what the empirical formula of a molecule would be and what the molecular formula would be. So when I was in college or in high school and I was learning this, to me it was kind of like a what's the point kind of thing. But when you study things like pharmacy, or you study things like, hold on a second, just said my internet's not that great again. Okay, when you study things like pharmacy or chemical engineering, things like that, you learn that ratios are really important when talking about chemical formulas. So that's what we're going to be today. So an empirical formula is just a formula that shows me all the elements that are present in that compound, and it gives it to me in the simplest whole number ratio. Molecular formulas, they are the actual chemical formulas of a compound, and they are not necessarily simplified. And I give you a good example of glucose. Everybody knows glucose from back in biology. You learned that glucose is C6H12O6. But we learned when we were studying how to balance chemical reactions that that is not reduced. So if we reduced it, it would be CH2O. But this is not glucose. This is glucose. A lot of our organic molecules are in non-simplified forms, and that's why we call them molecules, because that's their molecular formula. This is the actual formula of glucose. So when we're looking at this molecular formula, that's what this is, C6H12O6. This, hey, Sierra made it. This is CH2O. This is the empirical or simplified form of glucose. But if I put that on a piece of paper in a biology class, nobody would know that that was glucose, because this is just telling me that for every 1 carbon, there's 1 oxygen and 2 hydrogens, okay? So this is a ratio. All right, so what I want to do today is I want to start by learning how to figure out or determine what the empirical formula is. So those of you who just came into the class, we copied this when everybody was coming in. If you have not finished copying it, just take a screenshot real quick of this because I'm fixing to move it. So that way we can go on to working some problems. Okay. So if you've not gotten a screenshot or if you've not written this down, unmute real quick and tell me to hold on. If not, I'm fixing to move on.
How do I make it bigger so I can screenshot it?
Click speaker view. Whenever I'm talking, it should pop up. Let me see if I can do it as a share screen. Hold on.
I just tilted my phone sideways and it got bigger, so maybe that won't work.
Oops, not there. Nope, that won't work. Yeah, she said tilt your phone sideways. Did that work?
Yes, ma'am.
Okay. All right. So grab a screenshot of that and let's go on from there. All right. So let's look at what a problem is going to look like. So we're going to start by doing empirical formulas first. So let's do an example. Empirical formulas. And from here on out, I'm going to abbreviate this EF to save us some time. Okay. Okay, so this is going to be the problem that we're going to work with. A scientist in the lab has a 100-gram sample of diborane. This sample is found to be 78.1% boron and 21.9% hydrogen.
That's
1,000
grams?
100 grams, 100. Find the empirical formula. So we've kind of worked this the other way. Y'all have learned how to take a formula and determine its percent composition. Well, today we're going to learn how to take its percent composition and turn that into a formula, okay? So I like to do things like steps. If I can do a step, then I can work a problem. And I think steps are going to be the best way to work these problems, okay? So let's go ahead and just write some steps out. So step 1, I am going to change percents to grams. Okay, and this is as simple as saying 78.1% boron becomes 78.1 grams of boron. Ooh, that's hard. All right, so 21.9% hydrogen is now going to become 21.9 grams of hydrogen. Pretty easy, huh? Now, I will tell you, sometimes you don't even need to do this step. Every now and then you'll get problems where they've already completed that step for you and it'll say 78.1 grams of boron. So if you don't see any percentages in here, you can just go and say, skip step 1 and go on to step 2. Okay, so we're all good so far. Step 2, we are going to convert grams to moles. Convert grams to moles. So for this, we're going to need our periodic table. Okay, so I'm going to start with the 78.1 grams of boron. and I'm going to look at my periodic table, and I'm going to see that it is 10.81 grams of boron and 1 mole of boron. And then I'm going to take 21.9 grams of hydrogen. And I know in 1 mole of hydrogen, there's 1.01 grams of hydrogen. So that cancels out my grams. And I'm left with 7.22 moles of boron and 21.7 moles of hydrogen. Okay, so step 1, I change the percents in the problems to grams, just simply dropping the percent sign and writing a gram. Step 2, I'm going to convert my grams to moles. And I'm going to do that using the molar mass from the periodic table. So I'll look that up, and then I solve for moles. Okay. Step 3, divide each answer from step 2 by the smallest number of moles.
Hey, can you move that paper over just a little bit
Up or down?
to the side?
This
The other side. Yeah, that way.
This way?
Yeah.
Okay.
Mm-mm.
Miss Robinson is laughing at us, just so y'all know.
It's hard to tell you which way.
Yeah, I know. At least it's right way this way. Yesterday, or Tuesday, it was mirrored image, but I figured out how to fix that.
I just
Okay.
woke up.
I'm sorry. Well, Meredith, this has been like 6 straight class periods you've been on time. So apparently if you can learn while, laying in your bed, you'll be on time. Okay, so right here I have 7.22 moles and I have 21.7 moles. So obviously 7.22 is the smallest number. So I'm just going to go right here and I'm going to divide by 7.22 moles. And I'm going to divide right here by 7.22 moles. And now moles will cancel out. And when I work these out, I get 1 here and I get 3.01 right here. Okay, so change percents to grams, convert grams to moles, divide by the smallest number of moles, and now I have these 2 numbers right here. So, step 4. Use the numbers from step 3 as subscripts in your formula. So these numbers right here are now going to become my subscripts. So I'm going to write B, and since it's 1, that's an understood 1, H, 3.
Do you round it or you put the decimal?
Yeah.
You keep it whole number. Y'all say hello to
All
Coach
right.
Cooksey.
Hey. Hey.
Yeah.
So like if it was 3.8, we'd put 4.
Yes.
Okay.
And we're going to talk about when you can and can't round. But for right now, these are going to work out really nice and pretty, and they're going to be whole numbers, okay? There's a couple of them where they're weird, and we're going to look at a weird one in just a few minutes. But for the most part, they're going to be
So
pretty.
is that the answer? Is
That's
B?
the answer. This is your empirical formula. BH3. How easy is that?
Easy.
Not bad, huh? It's just steps. If you can follow the steps, you can work any problem. So let's do another one, okay? All right, I'm gonna move this one. Is everybody good? Can I move it? If I'm not, unmute and tell me. Okay, so let's do another problem. Okay, so analysis of a compound shows its contents to be 32.38% sodium, 22.65% sulfur, and 44.99% oxygen. Find the empirical formula. All right, so keep those steps close so we can kind of go through them together. So step 1, it's going to become 32.38 grams of sodium, 22.65 grams of sulfur, and 44.99 grams of oxygen. Step 2, I'm going to convert to moles. So use your periodic table and let's find our molar masses. All right, so Abigail, what is my molar mass for sodium?
I got 1.41.
All right, so 22.99 grams of sodium.
Oh yeah.
And 1 mole of sodium. And what did you get?
1.41.
1.41 moles of sodium. All right. Brittany Gudo, what is my molar mass for sulfur? 32 point.
01.
All right, 32.01 grams of sulfur and 1 mole of sulfur. And when you run that through your calculator, what did you get?
.01.
I think sulfur is 32.06.
It is. I don't have my
is.
work in front of me. I left it up in the classroom. All right, so let's do that one. So we have 22.65 divided by 32.06, and you get 0.706. I'm going to go 3 places after the decimal on these. It just makes things work out a little bit cleaner. You don't always have to, and for some of y'all, you won't want to, but my teacher in high school, Mr. Wood, always went 3 places after the decimal when it was less than a whole number. All right, then of course, oxygen is 16.00 grams of oxygen and a mole of oxygen. And so 44.99 divided by 16, and we get 2.812 moles of oxygen. Okay, so what's the smallest number, Sierra?
0.706.
Yep, so we're going to go divide everything by that. So now mole cancels out. And I get 1.997, which is the same thing basically as 2. And then this one, of course, is going to be 1. And then 2.812 divided by 0.706. That gives me 3.98, which is close to 4. Remember, I'm shooting for whole numbers here.
Do you want us to put the 0.00 after?
You don't. You don't have to. So now I'm going to use these numbers, and what are they going to become? Subscripts. I'm going to have Na2SO4. And this is my answer. Pretty easy, huh?
Mm-hmm.
Not bad at all. Okay, so there is one thing that I do want to point out. Let me show you another one that doesn't work out quite as cleanly. And I'm going to kind of work it quick because I don't want us to run out of time, because I think they're making us finish up lessons now within 40 minutes on Zoom for it to be free still. So I'm going to flip over, and I'm just going to do a quick problem real quickly here. This is a little one that's a little bit trickier. So on this one, I'm going to tell you we have 26.56% potassium, 35.41% chromium, and 38.03% oxygen. Okay. So just like before, we're going to work everything out like we just did. So I'm just going to work it out real fast, and you can just kind of copy it as I go.
Is that 36.08?
26.56, 35.41, and 38.03. Okay. So after I work all of these out, these are the numbers that I get for my number of moles. Okay. So looking at it, this is going to be my smallest number of moles. So I'm going to go ahead and divide everything by that number. And that's going to get rid of mole for me. And when I work it out, I get 1, 1. And on this one, I get 3.5. Okay. So when I look at this one came out really close to 1. Or this one was 1. This one came out really close to 1. 3.5 is not a good whole number, because 3.5 is right there in the middle, okay? It could go to 3, it could go to 4, and we can't round up on these, all right? So what I'm going to do is I'm going to come down here and I'm going to write KCRO 3.5. But we know from writing formulas that we can't have a fraction of an atom, okay? So anytime that we work something that doesn't work out pretty, we have to go in and we have to distribute a number through there. So I'm going to distribute the number 2. I start with 2. So that would become K2 CR2 O7. And that works out to whole numbers. So that means that that would be my answer. Now, if 2 had not worked, I would have gone to 3. And if 3 had not worked, I would have gone on to 4. You will never go over 4 in this class. So don't sit there and be like, you know, 62 and like, oh, it will not work. If you're on 62, you've wasted too much time, okay? So you try 2, try 3, try 4. So everybody always asks me, where do I know that I need to do that? If you get a number that ranges somewhere between 0.3 to 0.8, you will need to add this step 5, okay, which is where you just distribute a whole number through until whole number subscripts are met. Okay, so we only do that step if it doesn't work out pretty. I'm going to tell you right now, all of yours will work out pretty, except for every now and then you may get one that's a 0.5, okay? And you just need to know if it's a 0.5, you're going to have to multiply through 2. So is everybody good so far?
So you said if it's only 0.3 to 0.8.
Yeah,
that you do
somewhere
that.
between there. Like if you got 3.3 or 3.7, you would need to factor through a number.
But if it was any other number, you would round up around
Yeah,
now.
yeah, round up right. If it's 3.9, say 4. If it was 3.1 or 3.2, say 3. But right in
Okay.
here, it's kind of hard to round those. Okay?
All right.
So is everybody
Mm-hmm.
good? And I will tell you, if it doesn't work out real easily, you probably messed up somewhere in here. So before I started working on this step, I'd go back and check this because you probably messed up somewhere in here. Okay, so that's empirical formulas. Let's talk about molecular formulas. They're really easy. It's just a division, okay? So let me flip over to my molecular formula problems. Okay, so for molecular formula, we have a formula that we need to learn. Molecular formulas. Here is our formula. X equals molecular mass divided by empirical mass.
Wait, what's the X?
That's the number we're solving for.
Okay.
Okay. Typically, in like 99.999999999% of the cases, it will be big number over small number. Okay. And I tell people you can just remember X equals me, molecular over empirical. Okay. All right, so let's look at a problem. Okay, so let's say that the empirical formula of a compound is composed of phosphorus and oxygen and was found to be P2O5. The molecular molar mass was found to be 283.89 grams per mole. What is the molecular formula? Okay, so remember, molecular formulas are expanded formulas, okay? So this is the simplified or empirical formula of this. To find the molecular formula, I'm going to have to use that X equals M over E. So they tell me that the molecular formula mass or molecular molar mass is 283.89, but they do not give me the empirical mass. However, they do give me the empirical formula. So we're just going to find the molar mass of P2O5. So over here, I'll say 2 phosphoruses. So that'd be 2 times, what is the molar mass of phosphorus? My periodic table's on my desk.
30.97.
30.97 grams per mole. And then 5 oxygens is
I have
5.
a quick question.
Yeah. Yep.
Do we have to do we still need to write out grams per mole after?
Yes. Yes.
Okay.
Yeah.
All right.
All right. So 2 times 30.97 gives me 61.94 grams per mole. And then 5 times 16 is 80 grams per mole. So that's a total of 141.94 grams per mole. So this is my empirical formula molar mass. So now I can go plug into my formula. I use the molecular formula mass that they told me. I divide it by the empirical formula mass, which I just solved. And y'all divide that and tell me what you get. I
How
get
many places do you want to go? 3?
1. We're trying to do whole numbers. So do 1.
Gotcha. Okay.
So
Okay. So that 2 is now going to be factored through my empirical formula.
Okay.
I'm going to distribute it. So now it's going to be P what? 4 O
10.
10. And this is my answer.
Oh, that's simple.
It's not bad. It's not bad at all. It's super duper duper simple. Okay, so most people like this one because of the fact that it's got, you know, the numbers are pretty much given to you. Okay, so they're cutting us off at 40 minutes now on Zoom with the free component, and I don't want anybody to have to buy anything. So what I want you to do, you've got some problems that you can work on in your packet. Pages 10 and 11, you're going to turn those in, pictures of them, so that I can grade those. I would, since this is kind of fresh on your brain, I would start working on those problems. Kind of think of them as like practice of what we would normally do in class. And then if you get stuck or you have a question, you can just shoot me a message and then I can kind of help you walk through it. Now look, don't go to number 1 and get confused and go, okay, I quit. Let me text Ms. Fortenberry. If you can't do number 1, try number 2. And if you can't do number 2, go to number 3. Try to see which ones you can work and then go from there. I also want to tell you there's a lot of good resources that will help you to solve problems like this. So if you get bogged down and you're like, I can't remember what she said, go back and watch my YouTube video, or go Google or search on YouTube how to figure out empirical molecular formulas and walk through some extra problems, okay? Does anyone have any questions before we sign off? Okay, it's really not bad. Now I will tell you, there's going to be a couple problems they're going to push you, because they're going to give you this information like we got before, percentages, but then they're going to want you to find the molecular formula. So that means you're going to have to do both. You're going to have to find your empirical formula, find your empirical formula mass, then go do everything through this little formula right here, okay? But you can do this, all right? Y'all are all super duper duper smart. You can do this, okay? Does anyone have any questions? All right. Well, I'm going to sign off because they're fixing to shut us down. And if you're still having trouble, just shoot me a text, and we may do a little recap on Monday if we need to go over anything that anybody's having trouble with, okay? All right. Well, I miss y'all, and I will see y'all very soon, okay?
Alrighty.
Bye.
Bye.
Bye, y'all.
Bye.